Hi guys, Huey here. Good morning, afternoon, evening, good night, wherever you are. My continuing mission to explore the strange new world of Minecraft, to seek out new ways and new designs, and to boldly go and show what no one has shown before. Don't know if anybody knows to see what I did there. Anyway, honorable mentions I would really like to do is the one from Core Dumped. Please disappear, my Windows little thingy. Back to the game, thank you very much. The honorable mentions are the one from Codemt, where I learned a lot from how to program a CPU. Also very handy and interesting was the STEM Odyssey. I really learned about all the components that a computer exists of, that a CPU exists of, and so on. And again, going to Codemt, this is basically what I would like to implement in the little hexadecimal Minecraft computer that I'm going to build A to Z. Follow along A to Z and you will be able to do the same, because the only thing that missed me in the whole series and all the YouTube and videos and all that was the actual A to Z, how to really make something to build it. Doing it in hex because I did not want, also not want to spend days, hours, days, months into designing and all that. Saying that, I did spend already quite some time, because if you want to build this computer, you need a lot of components. And the most important component you need, I think, is obviously registers, which I already talked about. The hewie dot. But once you have the registers, you want to be able to read from them, write to them, and address them. And that's where the actual stacking comes in into a RAM. If you don't write to them, it becomes ROM. Same kind of story, same kind of thing. Building on the actual hewie dot, I have it somewhere there. You know, the hewie dot was a horizontal kind of organized register where I started looking into stacking them vertically, stacking them horizontally, stacking them vertically, sideways, whatever. Quickly noticed that the 5 wide was not really cutting it, because you have always a data bus line or data line, redstone signal wire, which is block compared to block dust, or dust block compared to block, or block compared to block dust. This one was already a design flaw or issue. 4 wide cuts it, so on comes the hewie dot 1. This is actually hewie dot 1.0. But then I have version 1.1 and 1.2. And then basically the idea is that you have, I'm not going to re-explain that you have a wire that sets by clearing it, writing it, and then you have a wire that reads it out, this one that you disable. Then started doing this horizontal hewie dot 1.0, doing it vertically, stacking them horizontally, stacking them vertically, stacking them on the z-axis, trying to remove this, trying to remove that. OMG, chiseling away, redoing it. It was like looking for a needle in a haystack. It really was, because there's 1,000 ways you can do it, but there's only one way I think that really works. The longest and the biggest issue was actually the control line of the register, because if you really want to, overshoot, if you really want to get the control line coming up through the middle, and you don't want the double, if you see the data bus going in, there's 1, 2, 3, 4, there's 3 wide now. But if you don't want that, if you want it too wide, there's no way. I have found no way of actually controlling the write to the data bus control and to the flash, the register control. Getting them both to come in through the middle when this is 2 ways. So this was born. A little bit more explanation about this little RAM design. This is Huey's RAM 1.0, because it really works. Same thing, the vertical register with the data in and the control data in with the right there on the crosshair the flash it or the reset it, the control line coming in, the data bus line here that then flashes the data onto the register, or this data read out, the read line that comes in through here. How did the data line is still up here. If I set the data line on, then it sets whatever is in the book. There's a 10 now, let's make it 12. There's a 12 on the data line now. Unhook the data line, and then downstairs we have the actual addressing line. And then I've done it this way that if you have the address, then there is power on this line, and then either you drop this block, powering this torch, unpowering this torch, unpowering the right outline, and then the register data will be on the out line, or you set the flash or the right line, dropping this, powering this, going all the way up. Oops. Yep, going all the way up and flashing what's on the data bus onto the register. You can stack them, and then the addressing actually looks like this. This is the start. This is important that the start is different than the actual rest of the addressing line. And then this is the drop one power going into the block, and then you have the same ID as address hexadecimal address busing, that you take bus number 1, and then you see torch number 1 is lit, and then so on. You can select, and then we say, for example, I want bus number 3, I want register number 3, I want on register number 3, I want a 10, I want a 10, I set a 10 on the bus, on the data bus, there's a 10 on the data bus, and I flash it. And then you see, I'm not too sure if you will be able to see, but you see that this line is boom. So they all go down, but there's only one line powered. And if all goes well, what did I check? Number, address number 3, and then 1, 2, 3. Here is a 10. Boom. And then I unset the address, the data bus, sorry. And then I have the same address selected, and I read it out, and then obviously it doesn't. Done. Little debugging. So it all goes down. I have my 3 register powered. Yeah, I need also a torch here, because no. Yeah, so sorry. I redesigned about the fact that I don't need a torch there, and I broke this block, and I forgot to put the actual repeater on, because now a little bit of stress, I have a 10. Yay! And then you can stack it as much as you want. It's not built for speed, it's not built for efficiency, it's not built for compactness, it's not built for anything. It's just built to do what I want it to do. It's address the register, flash whatever is on the data bus, and read out whatever is in the register. And then you can stack them, and now it's next to the following. Let's do another test. Do I have a number 5? I think so. I do have a number 5. Number 5 will be boom, 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 7. So 5 is 7. The data bus needs to be obviously on. So I get a 7 on the data bus. I flash number 5. I turn the data bus on, off, sorry, so it's off. And then I read out the 5 and haven't done anything. So this goes 7. And then if I leave the read and I just go to 3 again, it's 10. Ta-da! And so on and so on and so on and so on. Have fun. Building this, interesting. If somebody is interested in going through it A to Z, then please send me a little comment, text, or email. But basically, this is the use dot with its input data, output data, control line flash, and then the control line read. The control line read goes downstairs, goes down into a torch with a negative coupling, and then you have the all the blocks. It's you can do that without actually any tutorial. But I'm so happy to finally have an addressable read-write flashable register of, well, 15 addresses, 16 addresses, including 0. And that's the next step, is actually making sure that address 0 is always selected, and that when you go to 16, you actually select the next little chip, basically a little continuous, so that we can actually start building extended RAM. Have a lovely day. Take good care. It was most enjoyable to do this. I loved every single minute of it, even though it was sometimes very hard work. But I just love it, love it, love it. Have fun. Shoot me a line of text or comment if you have questions or want more information. Take care. Bye bye.